Hey everyone, thanks for joining this short session. We're going to talk a bit about developing SDKs in Kotlin multi-platform, and more specifically, if you have already existing SDKs. In this case, for us, I'm working at Sentry. I'm mainly working on our Dart and Flutter SDK, and maybe a bit on KMP SDK as well on the side. And yes, I'm a Flutter guy talking about KMP, so it's a bit weird. And also participated in the Google Summer of Code 23, where I had a project with some people from Google and JetBrains working on a KMP project as well. So a bit introduction. So Sentry is an error monitoring tool. So naturally, we have a lot of SDKs ready to use, and we support many different platforms. And in this case, it's kind of logical that we can use those SDKs, specifically our iOS and Android SDKs, to create a KMP SDK, which is basically a fancy wrapper around those. And we don't want to reinvent the wheel. We don't want to re-implement all those things because they're already mature. So might as well use them for Kotlin multi-platform. And I want to go through some steps in this talk about creating just a very MVP. And the first step here is how can we consume these native SDKs in our Kotlin multi-platform library, and then writing the public API. And then implementing those platform-specific things in Kotlin multi-platform, and then just a simple example on how it would look like from the user perspective in using this thing. So the first thing is, I want to quickly go through the project structure for this talk. It's very simplified. It's just Android and iOS targets. In the actual library, it's a lot more, just to give you this info up front. And the first thing is, how can we use these SDKs directly for Android? I think many of you probably know. It's extremely easy. In our Gradle file, we just add a dependency to our Android source set if you set up your Android target, and then that's it. Basically, you can then use it directly in your Android source set, and then you'll have access to all this stuff, to whatever the SDK is capable of. And for iOS, it's a bit more different. It's a bit more complicated. We have different options here. The first is to use the scener up tool, which allows us to create Kotlin bindings from whatever Objective-C or C headers we define. The tool expects us to have this .def file where we specify the language we want to create bindings from and the headers. And in this case, we can see that it's an Sentry SDK header, and this header is taken straight from our iOS SDK. As an example here, the actual SDK, the actual header file is a lot more larger, but I can just basically trim everything I don't need. I only care about creating bindings for this one function, at least for this MVP here, and that's it. And that's one of the advantages of this approach, where I can just pick and choose whatever I want to create bindings for. And then in your Kotlin build file, you just create this scener up with the build configuration as shown here. And then afterwards, you can just directly use it in your iOS source sets directly and interact with it. The other way is probably what most people will do on Kotlin multi-platform who are not writing libraries, is just using CocoaPods directly. And this is extremely easy. You just add the CocoaPods plugin and then just define whatever you want, and the CocoaPods plugin will directly do all these things for you automatically behind the scenes. And then you will do the same. You just import it, and then you'll be able to use it. So the main advantage of using the first option is that you can, as I showed, trim stuff. You don't need to do everything. You don't need to include everything from these headers to get bindings for. But the bad thing here is that if the API is not stable enough, you might have trouble breaking, or it might have trouble maintaining it because it might break, and then you have to readjust the headers again, and that's it. And the last point, I don't want to go too much into it, but you have to configure linker options for testing, because the tests don't know anything about the framework that's linked. So just a quick, I want to put it out there. I'm not going to go too much into it, but that's also a very big problem here. For CocoaPods, It's not a problem because CocoaBus will just pull everything in and do all this linking stuff behind the scenes. And that also means that you won't be as affected by API changes because depending on the version you pull in, it will just do its magic behind the scenes and do a scener up automatically. But the bad thing here is that it will create bindings for everything in your application. So even if you don't need everything, if you only need one function, it will still create all these Kotlin bindings for 20 functions, for example. So you have to really pick and choose your poison here and see what fits to your application. So the next step is, now that we've embedded these and we can access them in our platform-specific source sets, we can then define our public API in our common main. In this case, it's just a very simple entry point where we can initialize the SDK. And the main thing here is the Sentry Bridge class, which is just an expected class with an init function. And which brings me to my next point, is how can we implement these platforms specifically. And the platform-specific implementation here, which is the first variant I'm going to show, is the very basic one, which is just doing an actual and then using the underlying SDKs and initializing them using their respective functions, in this case, the init function. And the same for Android and iOS. But there's one step here in between, which is converting one type to the platform-specific type. So this options configuration uses a Sentry options type, which is defined in the common layer, which has to be converted every time to the platform-specific layer. And this might seem a bit trivial now, but if there's a lot of types you have to convert, it's a lot of bloat that you might encounter in your application. So the other option we could do is we could use the type alias key mechanism, which by definition is just adding in alternative names for existing types in Kotlin. And we can leverage this in KMP. So let's go back to this Sentry Bridge class. So the problem is we also need to convert the stuff. The Sentry options thing is always has always to be converted to the platform-specific options. And if you have multiple platforms, it can get quite big and a lot. So let's change that and let's do an expect on the Sentry options and add this simple DSN property with this nullable string. And then what we can do is we can use actual type alias, so we can directly use the underlying implementation, so we don't have to do any converting from one to another type. And this works, in this case, only for iOS. And the reason here is because our Android SDK is written in Java, so there's a lot of getters and setters. And in order for a type alias to work with expect actual, the signatures have to match exactly one-to-one. So the compiler will expect a variable called DSN that has a type of nullable string, but the Java SDK doesn't have that. It just has functions of getters and setters, so it doesn't know how to process that. And in this case, what are the options that we could do? The first thing is maybe just focus on one platform at a time and just do the standard way for the rest. In this case, maybe you want to focus on just type aliasing at least one platform and do the standard route of all this converting stuff for the other platform. And this might be good for if you don't have many platforms or if you're sure if you want to do this. But the other way is we could, for example, create an empty class and have an extension, in this case, extension property on this class. And it's also expected, or also has the expect keyword. And then in our platform-specific parts, we can then use the type alias directly because the empty body will pretty much type alias to nothing, so it will work automatically. And we can then access in our getters and setters inside this DSN property, the DSN that is inside the platform-specific options. It's not really clear here. I maybe should have written comments here, but the DSN in getters and setters are referring to the DSN of the platform-specific parts of it. So there's a way to work around that issue a bit. But in general, it has a lot of issues, but first I'm going to show you how it changes. So from this, we can directly then change the the code to make it so that it just calls in directly without anything, without any layer in between. So what about companion objects? I'm mentioning this because companion objects are also often used, and we can also type alias them, but it will not work directly if you work, for example, in Java, because companion objects, well, they do not exist in Java. You use a static keyword, so the compiler also doesn't know how to handle that because it expects another companion object. So in this case, what do? We just ignore it and do it anyways. But make sure you test it, and so it doesn't crash in runtime. This works because it just, as long as you call it the same way you would call it in the respective platform, it will work. And to show you, I'm not the only one. This is from Ktor. They're also ignoring stuff, suppressing stuff. So, but please test it beforehand before you try to use this. Yes, so just a quick introduction into how you can use this thing. So in your common main, you just implemented the library, and you also have to add this. You don't have to use CocoaPods, but it's one way to add the framework to your library, because the binaries are not really packaged when you publish a library, at least not the packages for your iOS SDK. So you have to do this. And in your common main, then you use that thing, you use the init that we did, that we specified, and then wherever you want to use it, just call it, and pretty much that's it. Then you have a working MVP. You can use init, and it will then automatically call the initialize function of each platform that you specified. So quickly to summarize, try to expect actuals with type alias. It's pretty fun, but it has a lot of caveats. So if the project or if the underlying types are very complex with generics and a lot of inheritance, whatever, it can get complicated. It might not even work. It might not even be worth it. But maybe for simple data objects, maybe that's a good case to try it out at least. And senior op, I think it's a good thing to learn at least a bit. And it might be useful to use in SDKs if you know the API is stable, but otherwise just use CocoaPods. Otherwise, if you really care about sizing, then you might use tiner op and then just cut everything from the headers you don't need. And also last thing, the SDK could also just be a boring wrapper. It doesn't have to be fancy. Use whatever is available to you, and that's it. Thanks for listening to my talk. If any of you have any questions, then feel free to ask them.